All right, welcome back, everyone. Today we're going to be looking at parallel and perpendicular lines. And this can be practiced in IXL on S28, slopes of parallel and perpendicular lines. Let's go ahead and get started. Okay, parallel and perpendicular lines. First of all, I've given you a bell work to look at to kind of illustrate this before we actually got into the lesson. So please go ahead and graph these two lines, pause the recording, and go ahead and graph those. Okay, so hopefully you have these two graphed. I'm going to actually use a table to kind of illustrate a point here. Okay, so I put a table for each one of these. This is a table for the first line. This is the table for the second line. Let's start with the first line. Okay, so on the first line, and I'm going to go ahead and let x equal 0. I could have picked any number I wanted. As you know, there's an infinite number of combinations of x and y that will make this line true. Okay, so if x equals 0, 2 times 0 is 0. 0 plus 3 is 3. If x is equal to 0, y is equal to 3. Okay, let's go ahead and pick another x value. Let's just go ahead and pick 1. That's pretty simple. 2 times 1 is 2. 2 plus 3 is 5. If x is 1, then y has to be 5. And of course, you could do this infinitely for an infinite number of points. I'll just go ahead and throw another one on there. If x is 2, go ahead and pause it. Did you get 2 times 2 is 4, 4 plus 3 is 7? Good. So you get the idea. There's several of the points that are on this line right here. So now, let's go ahead and look at this line right here. Okay, so let's go ahead and let x equal 0 here. 2 times 0 is 0. 0 minus 1 is, if x is 0, y has to be negative 1. Let's go ahead and try 1 again. Okay, there's 1. 2 times 1 is 2. 2 minus 1 is 1. So here, if x is 1, then y has to be 1 as well. I'll give you one to work on your own. 9, go ahead and pause it. Okay, you should have had, oh, there's that bell. You should have had 2 times 9. You should have 2 times 9 is 18. And 18 minus 1 is 17. So that gives you a general idea of how you can fill these tables out for these two lines. So now let's go ahead and use these two tables from these two linear equations, and let's plot both of these lines. Let's graph these lines. Let's start with the first one. Okay, so I'm going to go ahead and work on this first line here. 0, 3. So 0, 3 is the first point. I'm getting that right here. 0, 3. I could use my slope, but I'm just going to go ahead and use the second point. 1, 5. And there we go. I now have my first line. And now I'm going to go ahead and work on my second line. The first point on that would be 0, negative 1. This is this line right here. So 0, negative 1. Okay, and then my second point would be 1, 1. So 1, 1. And there you go. And I could have plotted all those points on that. Now, here's the question that I have for you, either from your original sketch or from this one. If you were a sixth grader and you walked in and kind of saw these two lines up on the board, what might you think about those two lines? So if you said parallel, yeah. And a sixth grader would say, well, they're parallel because it looks like they go on forever and never touch. Of course, you cannot do that with a graph because we can't draw perfectly parallel lines, even the greatest computers can't. But there is one way we can tell for sure, and it's not from looking at a picture. There's really only one way to tell for absolute certain that these lines are parallel. Right here, the slope. This one goes up 2, right 1, up 2, right 1, up 2, right 1. This one also goes up 2, right 1, up 2, right 1. And since they don't cross at the same place, these two lines will go on forever in this direction and never touch, and they will go on forever in this direction and never touch. So that gives you an idea about parallel lines and kind of a review on that. So let's go ahead and look at that right there. There's the first one. Okay. And there's the second one. Okay. So let's go ahead and look at parallel and perpendicular. So here we have two lines. They look parallel. Are they? You can't tell. Line A and line B, they kind of look like they might be. But the only way you can tell is if it actually says these two lines are parallel. Like if you're reading, it says line A is parallel to line B, and they might put it in notation like this. Line A is parallel to line B. So A is parallel to B. And the way that you tell the definition of parallel lines is that they have the same slope. So if these two lines have the same slope, then they are parallel and they don't cross anywhere, okay? Second possibility would be, what if two lines cross? Well, two lines cross here. Parallel lines share no points. You might remember that from another lesson. And lines that cross can only share 1 point. But if they cross at right angles, that's what this is for. If they cross at right angles, then these are perpendicular. So this you can actually tell from a picture because it tells us that that's a right angle. And if that's a right angle, all 4 of these are right angles. So that tells us that it's perpendicular. Or it could say perpendicular in the sentence, or you could use notation. A is perpendicular to B. And what this means is opposite reciprocal. And we'll get more into that here in a moment of what opposite reciprocal means. Opposite means if it's negative, then it's positive. If it's positive, then it's negative. And reciprocal just means flipped upside down. The reciprocal of 2/3 would be 3/2. The reciprocal of 5/7 would be 7/5. The reciprocal of 2 would be 1/2 because 2 is 2/1. And we'll look more closely at that again. And again, the third possibility is that the lines touch everywhere. And if they touch everywhere, they are the same line. And if they are the same line, then that means that they have the same simplified equation, that the equation of both lines will be simplified down to the same thing. And we'll look at that more in detail on the next one.